Imagine waking up one morning to a military assessment that delivers a blunt, unsettling sentence. Your most advanced long-range strike weapons, the tools you rely on to keep an enemy at arm's length, could be exhausted in a matter of weeks if a large war breaks out. Not months, not years, weeks. That stark finding is surfacing in war games, policy studies, and in the hard lessons drawn from the fighting in Ukraine. The cold truth is this: technological superiority does not automatically translate into staying power. The real question now is not only which systems are better, but whether the nation will have enough of the right systems when the shooting actually starts. The Russian invasion of Ukraine forced a hard reappraisal of old assumptions. We watched sophisticated systems achieve remarkable effects, precise strikes, deep interdiction, and sensor fusion that once seemed the stuff of science fiction. Yet the conflict also revealed a brutal arithmetic. Quantity changes the game. No matter how capable a weapon is, it is rendered ineffective if a campaign burns through stocks faster than factories can replace them. That arithmetic bites especially hard when you talk about high-end standoff missiles. Packages like Lockheed Martin's JASSM-ER and the LRASM family cost millions each and take time to build. In a campaign that demands hundreds or thousands of strikes, that cost and that production tempo can turn strategic advantage into an operational liability. Wargames from centers like CSIS repeatedly highlight scenarios where a force runs short of high-end munitions within the opening weeks of a high-intensity fight, and those exercises are not academic warnings, they're practical alarms. If the problem is how to deliver more effects to the battlefield faster, the answer is simultaneously simple and unsettling. Use what you already have, in greater volume. Rapid Dragon, the Air Force Research Laboratory's palletized missile concept, embodies that approach. The idea is straightforward. Load missiles onto pallets, roll them out of cargo aircraft such as Cone, 130 seconds, and C-17 seconds, stabilize the pallet, and release missiles into flight from a relatively safe standoff. Aircraft that currently move supplies become arsenals. The pallet is cheap, the aircraft are ubiquitous, the effect is massed, distributable, and hard to predict. In short order, a transport fleet becomes a launch fleet. Running alongside that operational innovation is a change in the weapons themselves. Defense firms and new entrants are building lower-cost cruise missiles weapons, priced in the low hundreds of thousands rather than millions, with modular payloads and simplified production processes. Names to watch include COMET and Anduril's Barracuda 500M, while systems like the ADM-160 MAL-J add an essential electronic dimension by jamming and deceiving enemy sensors. Combined, Rapid Dragon and these compact missiles let planners trade some degree of sophistication for sheer numbers and flexibility. The clearest litmus test cuts through rhetoric to ask one simple question: what is the cost per effective hit? That's where the debate between kamikaze-style cheap drones and slightly pricier low-cost cruise missiles converges. Consider Shahed-style loitering munitions as a case study. Early import prices were reportedly as high as roughly $290,000 apiece. Russia then invested on the order of $1.75 billion to transfer technology and establish domestic production, driving that unit cost down to an estimated $50,000. That looks like a bargain until you account for effectiveness. If only 10% of those weapons reach their intended targets, the cost per successful strike balloons to about $500,000. Now, consider a low-cost cruise missile built for precision and mass production at, say, $150,000 per round. If that missile achieves a 30% probability of effect under operational employment, the cost per hit falls to roughly $495,000. The arithmetic is counterintuitive but decisive. Paying more per round can make you cheaper per outcome. That is the heart of the low-cost cruise missile argument. Beyond raw economics, smaller, modular missiles reshape storage, transport, and launch options. A small diameter missile that fits inside a fighter's internal bay or on a pallet reduces logistical strain in ways that large drones cannot match. Quantity is a strategic variable. Once equipped with transfer agreements and tooling, an adversary's production line can churn out Shahed-style systems in huge numbers, reported daily outputs in the 170-190 range. By contrast, Western production of high-end missiles often counts only hundreds per year. The asymmetric pressure that creates is obvious. A steady torrent of attritable, low-cost weapons can erode defender inventories, force expensive interceptor expenditures, and produce cumulative effects through sheer attrition. That asymmetry is precisely why strategists now talk about a high-low mix. The West is not abandoning high-end munitions. JASSM-ER and LRASM remain essential for certain missions, but a layered approach appears necessary. Cheap missiles and drones can overwhelm or deceive defenses, drawing away expensive interceptors and exposing key targets to higher-end strike assets. Campaigns might not hinge on a single knockout blow. Instead, they will be shaped by persistent, distributed pressure that grinds down an adversary's capacity to respond. Logistics, the unsung battlefield, often decides whether a plan is clever or actually executable. Size and storage matter in wartime. A single C-130J cargo bay, based on published dimensions and open-source imagery, can carry roughly 30 Shahed-sized drones if packed tightly. Swap in compact, Comet-sized missiles with diameters designed to fit internal weapon bays, roughly 18 inches or less, and that same space can hold far more rounds, potentially hundreds. That multiplication factor is not trivial. When you pair it with palletized Rapid Dragon launchers pallets that could carry a dozen or more missiles and be launched from many aircraft types, the logistics multiplies combat options. Industry briefings suggest a C-130 sortie could launch on the order of a dozen missiles, while a C-17 might dispatch as many as 45 in a single employment. Those are not fanciful figures. They alter how a theater can be supplied with effects. Operationally, this means the US can use its transport fleet to create surprise and distribute launch axes unpredictably. No longer are adversaries able to model attacks solely based on fixed ground launchers. Air-launched pallets complicate defense planning and compress the replenishment cycle. If weapons are compact, standardized, and pallet-compatible, resupply becomes far less of a constraint during sustained operations. The trade-offs are stark. Cheap kamikaze drones are inexpensive for a reason: simple airframes, low-cost propulsion, and limited sensors. They are, by design, expendable. Their strategic utility often lies in forcing an opponent to burn expensive interceptors. The downside is a low single-shot success rate, perhaps 10 to 15%. That can be tolerable if you can produce tens of thousands, but it is inefficient when targets are high value or heavily defended. Low-cost cruise missiles aim to invert that calculus. Built to be good enough, they offer higher hit probabilities and can carry modular roles: kinetic, ISR, decoy, or jammer, while remaining cheap enough for mass procurement. The goal is sustainable effectiveness over campaign length, not parity with top-tier precision missiles. Modern warfare is also an electronic and cognitive fight. Systems like the ADM-160 MAL-J demonstrate how signature augmentation and jamming multiply the effect of massed fires. Hundreds of Horizon-launched decoys can present radar returns that mimic manned aircraft, while jammers blind or confuse guidance and fire control. In that environment, defenders must allocate interceptors, sensor time, and command attention across a smeared battlefield. The swarm becomes both physical and cognitive. It targets enemy decision cycles as much as it targets physical infrastructure, increasing attrition on expensive defense systems. None of this is a panacea. Mass production presumes a resilient industrial base and supply chains that can surge during wartime. Rare materials, specialized electronics, and skilled labor could become bottlenecks. There are political and reputational costs to firing thousands of weapons, and legal and ethical constraints when operations occur near civilian infrastructure. Scaling production quickly also requires policy choices that are politically difficult: funding lines, contractual incentives, and acceptance that some munitions will be intentionally expendable. The remedy is not just technological, it is institutional. The Department of Defense and policymakers must incentivize modular design, reward surge production, and bring non-traditional manufacturers into the defense industrial base. Doctrine must evolve to treat massed fires as an operational resource to be planned, conserved, and integrated with high-end precision. Allies matter. Shared stockpiles, interoperable pallets, and coordinated sortie planning can deliver surge effects no single nation can manage alone. Coalition inventories and synchronized operations could produce mass without forcing any single partner to shoulder a disproportionate burden. This conversation also forces a cultural shift in procurement. Western acquisition has long favored complexity and capability, pivoting to a model that prizes modularity, simplicity, and surge flexibility requires bureaucratic will. Policymakers must accept that some munitions will be intentionally inexpensive and designed to be expendable. That is politically uncomfortable. But the alternative, watching stocks dwindle mid-crisis while complex systems trickle off assembly lines, is worse. The strategic lesson is simple and stark. Deterrence and warfighting are two faces of the same problem. You must be capable enough to deter, but also prepared to fight at scale if deterrence fails. A credible posture needs both exquisite precision and abundant, affordable effects. Achieving that balance will be messy, expensive, and contested, and it must begin now. Otherwise, when the next crisis arrives, the bitterest regret will not be that a weapon failed, but that there simply weren't enough to use. How a country with the world's largest defense budget converts concepts into durable advantage. The solutions are not glamorous, and they are not sudden. They are bureaucratic, industrial, and political, but they are decisive. First, industrial policy matters. The United States possesses unmatched technical depth, but historically it is not always optimized for surge. Building a missile in peacetime under fixed contract rules is not the same as fielding millions of expendable rounds when conflict breaks out. That difference is the crux of the challenge. The Pentagon must shift some procurement toward the logic of scalability, modular designs, simplified electronics, and supplier networks that can be expanded quickly. Contracts should reward manufacturers that demonstrate capacity to ramp, not just low unit costs. Surge clauses can be embedded in agreements now, so that when a crisis threshold is triggered, production can expand without bureaucratic delay. Second, logistics must be treated as strategy. The math of how much a C-130 or C-17 can carry is not trivia. It is a planning variable with strategic consequences. The Defense Department should standardize pallets, launch mechanisms, and communication protocols so that missiles and decoys are plug and play across platforms and allied stocks. Rapid Dragon demonstrated the concept. Now it needs routine operationalization. That means habitually training crews to load, secure, roll out, and initiate palletized launches under stress, in degraded GPS conditions, under electronic attack. It means hardening the command and control links that sequence mass launches so that a theater commander can choreograph dozens of launches without every pallet requiring bespoke solutions. Third, doctrine and training must catch up. Executing massed fires is not just an engineering problem, it is a tactical and operational art. Commanders need playbooks for integrated saturation operations. When to throw a swath of decoys, when to consume a pallet for suppression, when to preserve stockpiles for a decisive strike. War games should incorporate logistics, attrition variables, degrade sensor feeds, and force officers to manage inventories as an explicit part of campaign planning. The awkward reality is that we will not always want to expend cheap missiles for theater-level signaling. Commanders must learn to treat expendables like ammunition in the old battleship age, a resource to be apportioned, conserved, and used for effect. Fourth, alliances are force multipliers and they must be operationalized. NATO and other US partners can pool inventories, harmonize pallets and launch systems, and coordinate surge plans so that the industrial burden is shared. Interoperability means more than compatible radios. It means standardized missile pallets, shared logistics nodes, and legal arrangements for cross-border stock movement in crisis. Coalition production lines and joint contracts can multiply output and reduce single-point vulnerabilities. Political alignment also matters. A coalition that commits to shared surge mechanisms conveys credible political will and reduces the likelihood an adversary can isolate a single state. Fifth, posture and signaling influence. Deterrence. Demonstrations of surge capability are not just for show, they are strategic messaging. A compact, visible capability to mass and sustain strikes undermines an adversary's calculus in ways that a single exotic platform cannot. Public, controlled demonstrations, combined with discrete intelligence that signals production capacity and dispersal plans, can force an opponent to factor in the risk of enduring attrition. That is deterrence by resilience. Not only can you strike, but you can continue to strike until the adversary's will or capacity breaks. Sixth, legal and ethical frameworks must be proactive. Mass employment of expendable weapons raises real concerns about discrimination, proportionality, and the risk of collateral harm, especially in urban or contested spaces. The Pentagon should invest in improved targeting data, enhanced battle damage assessment, and transparent policies that articulate how massed fires will comply with international law. Clear, pre-planned rules of engagement for surge operations, combined with accountable post-strike reviews, will help maintain moral authority and reduce blowback. These processes also improve effectiveness, better data and legal clarity, reduce the risk of wasted ordnance on poorly identified targets. Seventh, technology strategy should emphasize manufacturability alongside capability. Research and development should embrace commonality and part standardization, favoring components that are commercially available and avoiding single-source, exotic items that create bottlenecks. Digital engineering tools, automated assembly lines, and modular electronics should be prioritized so that a design can be rapidly instantiated in multiple facilities. The aim is not to degrade performance, but to design with scale in mind. A missile that is slightly less complex but can be built in huge numbers is more valuable in a prolonged conflict than a superb weapon that arrives too slowly. Eighth, broaden the industrial base. The Defense Department should lower entry barriers for non-traditional suppliers and create pathways for small and medium-sized manufacturers to produce subcomponents or conduct final assembly. Firms from aerospace, automotive, and even advanced manufacturing sectors have capacity that can be tapped. Certification pipelines should be accelerated during peacetime, so suppliers are qualified and ready when surge contracts activate. Diversifying suppliers reduces choke points and increases resilience to targeted disruption. Ninth, the fiscal argument must be candid. Abundant, cheap missiles require investment. They do not replace carriers, fighters, or satellites. They complement them. Budgets must allocate funding for warm production lines, stockpiles, and surge contracts as an insurance premium against strategic surprise. The alternative, relying exclusively on exquisitely capable systems while neglecting volume, is a false economy if wartime demands outstrip production. A clear, transparent accounting of costs and benefits will make the political case easier to sell to taxpayers and legislators. 10th, tell the public story. Democracies require consent for sustained defense postures. Military and civilian leaders should explain why expendable munitions preserve precision and reduce long-term human and material costs. For an audience aged 40 to 65, the messaging should emphasize prudence, preparedness, and moral constraints, showing how modest peacetime investment can prevent strategic shortages in crises. Transparency builds the political cover needed to fund surge-capable architectures and to maintain the will to sustain long campaigns if necessary. 11th, institutionalize experimentation. Temporary pilots are useful, but the real change comes from embedding experimentation across the services. Regular joint exercises, allied interoperability trials, and live fire rehearsals under contested spectrum conditions should become institutionalized. Lessons from these exercises need to feed acquisition, doctrine, and industrial policy in short, auditable cycles so that what is learned in the field shapes what is bought in the factory. 12th, prepare for the political friction. Some constituencies will resist the notion of expendable munitions. Defense acquisition cultures prize capability. Industry profits from complexity. Confronting those realities demands political leadership prepared to make the case for trade-offs. It also requires mechanisms to preserve innovation for high-end platforms, even as production lines create volume for lower-tier munitions. This is not a zero-sum choice. It is a choice to diversify means, not abandon ends. What does success look like in practice? It looks like cargo fleets that routinely train as launch vectors, industry contracts that reward surge and speed, allied stockpiles that can be pooled and dispatched, doctrine that treats massed fires as a routine operational tool, and legal frameworks that protect civilians while enabling decisive action. It looks like political leaders who fund warm lines and accept some weapons are intentionally expendable for the greater strategic good. The alternative is glaring. Advanced munitions that run out leave commanders brittle and choices narrow. Technical superiority without strategic depth becomes a liability when a campaign requires sustained effect. Recent conflicts teach a simple lesson. Resilience matters as much as sophistication. The United States can achieve both precision and volume, but only if it changes not just what it builds, but how it organizes industry, doctrine, alliances, law, and public understanding around the reality of large-scale war. Act now, build capacity, preserve precision, and be ready for the future today.